Hey everyone, welcome back to the Build Squad stage. I'm Jane, I hope you all are enjoying your time in Denver. Very excited to announce our next speaker. We have the co-founder of Tezos. His name is Arthur, and he's going to talk about too many L2s. So Arthur, please join us on the stage. Handing this off to you.
Thank you. All right, so the title of this talk is Too Many L2s, again for Enshrined Monolith. And AI agents and Memecoin is bait, sorry. It's going to be more of a talk about how to properly scale an ecosystem with rollups. So let's get started. All right, so Ethereum has too many L2s. I think it, but I'm not the only one saying it. I think a lot of people look at it this way. And, it's great when you have, it's great that people are building L2s, but if you have a proliferation of L2s, what do you get out of it? You get fragmentation. So that means scattered liquidity, because all of them are trying to spend millions and millions to bring liquidity to their own chain. So you also get limited interop, because they can't really talk to each other that well. You can bridge assets, but you can't really have smart contract calls from one to another. And that's essentially the little to no composability that you get out of it. So from a user perspective, this is not great, right? The user does not want to use 20 different L2s. It's not a good user experience at all. And there are solutions being proposed, but I would say that all the solutions are essentially band-aids. So they can interact, but natively, and by that I mean they can move assets from one to another. I think that's one of the big advantages of an optimistic rollup, or a rollup in general, is that you essentially have a trustless bridge to the base chain by default. So they can do that. However, in order to do it quickly, they essentially need bridges, which adds a lot of friction. Those bridges are always custodial on some level. It's like every single bridge protocol out there saying that they're non-custodial, you scratch a little bit. It's like, yeah, it's custodial. They say, oh, we're non-custodial. You pick the addresses that control the bridge. All right, so, someone's a custodian. There's really no good trustless bridge that exists out there. There are some bridges which use light client level security. They're the exception on the rule because they're kind of hard to maintain. And even some of those are going to have special keys that let them be upgraded. So you have a form of custody in all of those. And then, they'll slap a token and slap some governance to kind of claim that it's non-custodial, but it is custodial. All right, so we don't really have a good way of, and that's only for moving assets, by the way, right? You're not even talking about doing calls here. We're merely moving your assets from one chain to another. And so ZK can be better. So the nice thing with a validity rollup, as opposed to an optimistic rollup, is that you don't have to wait a long time to move your assets from one chain to another. You can potentially do that very quickly. So they'll give you trustless and fast interrupt rollup transfer. So that's good. Maybe if you have some shared sequencers, you can get a little bit, you can squeeze a little bit of composability out of it. But they also add a lot of complexity to your implementation, and they add a massive overhead. So you have, you can look at it as a trilemma. These are popular. So what do you want in a rollup? You want the rollup to be versatile or compatible in the sense that you want to be able to run smart contracts, you want to be able to run compile codes, you want to be able to run all of these complicated things, and not necessarily just a very narrow set of instructions. You want a reasonable cost. And I'm here talking not just about gas, but the actual cost of running the computers, making the proof, and you want high throughput, and you can get basically 2 out of 3. You could severely limit the type of operation you allow, and then maybe you'll get high throughput at a reasonable cost. You can have versatility and high throughput and massively scale in your proving setup in parallel, but the cost will be immense per transaction. Or you can let go of high throughput, you'll be versatile, have reasonable costs, but your proofs are going to take forever. So it's not it's still not quite there, and there are fundamental reasons why the cost of ZK proofs, even if you have better circuits, even if you have better techniques, even if you use ASICs, there's still going to be a bit, at least a few orders of magnitude overhead in compute costs compared to just running code. So the underlying problem is that the fraction also comes from a lack of alignment, fundamentally. It could be a lack of alignment in terms of the culture, like what is the vision, what is the mission, what is the ethos of this. In terms of the technical viewpoints, the protocol development, governance, research tooling, none of that is aligned. They're all kind of like working in their own direction. And the economics, right? The individual projects have their own agenda, they have their own tokens, and the whole ecosystem is not necessarily aligned around that. So what I'd like to do is make the case for enshrined monolith. So what is that? So first, the monolith part is monolithic. There is no fragmentation in an enshrined monolith. You have full composability. And the idea behind it is like, when people think monoliths in general, they don't really think rollup, right? They think of rollup as a way to scale horizontally. You're going to have many rollup. Isn't having many rollups the whole point? And we just need to solve how they're going to interact with each other. What people fail to see is that rollups can scale vertically. Rollups are a great way to scale vertically. And the reason for that is the trust assumption for a rollup and for a main chain are different. For a main chain, everyone has to validate every transaction, but everyone is also the set of people guaranteeing the integrity of your chain. Now, if you want your chain to be censorship resistant, to have all these group properties, you need to have many, many validators. You want your validators to be very decentralized. You want the cost of being a validator to be very cheap. That's all good. However, you need to distribute all of that data, all of that computation to all of these validators, and that's very expensive. With a rollup, with an optimistic rollup, you have a single honest party assumption, which is great, right? It's a lot easier to convince yourself that you're going to have one honest person rather than convince yourself that you're going to have a majority of honest person. I'm much more comfortable with just needing one than a whole majority. And so you can have very, very different assumptions. You don't need as many validators as you would for your layer one. And that, in turn, lets you scale vertically without the centralization aspect that would come from trying to scale vertically a layer one directly. So there's a lot of benefits that come from scaling via a rollup. You want to scale your L1, well, don't scale the L1 directly. Make the L1 minimum, make the L1 focus on what it's really good at, which is consensus, and then scale vertically within a rollup. And then there's the enshrine part. So what does an enshrine mean? It means first that the functionality of the rollup is implemented at the level of the protocol directly. It's not a smart contract. Rollup as a smart contract can be very hard. Smart contract languages today, they're limited. It's tricky to get the complexity of something like a whole rollup. Specifically, optimistic rollup, it's a little better with zero knowledge proofs, because with a validity rollup, all the complexity is in your prover, whereas the part that's on-chain can be simple. But nonetheless, it's quite difficult, and the idea of being enshrined and canonical in some sense, it promotes alignment. You're not just some project running on top of the chain, you are just an extension of the chain, and that makes a big difference culturally and economically. So that's the idea behind Tezos X. Tezos X is a high throughput rollup being developed on top of Tezos, and the idea is that it becomes the canonical rollup for all activity to take place on. It doesn't mean that you can't use another rollup if you want, but by default, this is the idea is to move the activity there. The goal is to have very high performance, interop, meaning support for mainstream programming languages, be they Python or JavaScript. Essentially, you want to be able to take whatever will run normally on the machine and run that directly. And that comes with support for low-level support for RISC-V. So no fiddling with a custom VM or fiddling with a custom programming language. This is not. We're not talking about also, something that looks like JavaScript. We're talking about something that really is JavaScript, where you can import libraries, do all of that, follow exactly the type of development environments you have for any other development. And high composability between all of that. So, whether you're building a contract in JavaScript and you want to call someone who's built their contract in Python, you should have interop. The modulity design, the idea is that there's modules, but it's also monolithic scaling. So you have consensus with a lightweight L1, and Tezos is very lightweight in terms of the cost of running it. Publication on a data availability layer, which is the peer-to-peer network secured by the layer 1. It works with data availability sharding, essentially. And execution, you have a canonical rollup, which is a big enshrined monolithic L2. So technical benefits. Is enshrined, it's non-custodial, it's secured and governed by L1. It is true today that a lot of rollups are actually custodial. They might have a lot of code in there that could almost allow them to be non-custodial, but if there's someone controlling the keys to the rollup, if there's someone that can upgrade the rollup with a piece of keys, then essentially those people can control the rollup. Those people can hack the bridge. Those people can steal assets from the rollup. It's custodial. So if you look at the rollup today, like Base, it is 100% custodial, right? It might mean, it might be nice, it might be doing some nice things, but it is 100% custodial. No fragmentation, full composability. So you're not talking about having many different rollups where maybe you have bridges. No, everything talks to each other. You can support different execution environments in parallel. And also the throughput is not a concern because with vertical scaling, you can get a ton of throughput out there if you think about it. And I'm not even talking about trying to have parallel execution. Forget parallel execution. Imagine that you have a huge state, you keep your state all in RAM, you parallelize signature verification. Now, if you've parallelized signature verification and your state is in RAM, a transaction is just moving a value from one place to another. You should be able to do millions of transactions single-threaded. I'm not talking about verifying 1 million signatures. That you need to parallelize. But a transaction, that should not take that long, right? So I think there's a lot to be done with multiple core, but even on a single core, you can go really, really far and gain and retain a lot more composability. But there's a non-technical benefit, there's a security benefit that comes with it, which is social consensus. A canonical rollup is not just a smart contract, it's an extension of the protocol. And what comes with that is that every protocol today will fork to protect itself, right? If you have a bug tomorrow in Bitcoin, Bitcoin will fork. It has happened, by the way. If you have a bug in Ethereum, Ethereum will fork. That is true. But it will not happen for a hack. It will not happen for a bug in a smart contract. And that's, it might seem like it's not a technical difference, but it's a massive difference. It changes everything. If you're saying no. The protocol, which is a ground source of truth, essentially, you can use the whole social consensus of the protocol. You can use the whole weak subjectivity of the protocol to protect the rollup. When you look at the complexity of the implementation of rollup today, be they optimistic rollup or ZK knowledge, or validity rollups, that makes a huge difference. It is extremely important, and you do not get that when you outsource the development of your rollup to a VC-backed company. That's just not going to happen. So Etherlink is the first step that we've taken on Tezos. Its tagline is fast, fair, and nearly free. Nearly free because transactions are extremely cheap. It's fair because there's a sequencer that's elected, but it can be replaced. And we're working on code to blind the sequencer from the transaction. Not yet in place, but upcoming. And fast because we have sub-second latency on confirming transaction. It's EVM compatible, so drop-in replacement for any Ethereum or L2 that you might want to use. Sub-second latency, minimal fees. It's enshrined. It's completely governed by the L1. It's an extension of Tezos. And there's a token on Etherlink, and that token is called Tez. There's no reason to have a separate token for it. The playbook today is you launch an L2, maybe you sprinkle a little bit of technology on it, what does the playbook look like? Okay, you launch an L2, you're going to keep 90% of the token for yourself. You're not going to pretend it's for yourself. No. You're going to have a pie chart, and you're going to divide the pie chart in 20 pieces. It will be that piece is for liquidity provider. That piece is for community incentive. That piece is for liquidity incentive. That piece is for team. That piece is for investors. You got it, but no matter how you look at it, about 90% is held, by insiders. And then you use that to create massive incentives to bring back TVL. You'll bring some TVL for a while. TVL will go out. What else do? You either say you're going to be very high throughput, so you have a little bit of technology here and there, or you try to add some yield in some form. But eventually, it's a bit all of the same. And when those tokens end up being unlocked, you're left with no TVL and nothing. So no, this is just an extension of Tezos. It can make for a less flashy launch, but it's definitely more robust. Next steps. So Etherlink plus data availability, because we're launching data availability on Tezos. So the data availability sharding, which is, if you're from the Ethereum world, you're probably familiar with dank sharding. So it's very similar to that, using zero knowledge proofs around sharding your data with error correcting codes. So you can publish on a data availability layer, which gives you even more throughput and execute via Etherlink. But we have more coming. And so this is all going to be part of Tezos X. The idea is to merge all this. So first, you fan out and then you fan in. And as part of this fan out, we have Justice, or JSTZ, which is a JavaScript compatible rollup. Real JavaScript, you can use node environments, you can use JavaScript libraries. All of that is, if you're a web developer, this is exactly the type of environment you're used to. Tezlink, which is a Michelson rollup. So this is for all of the builders who built over the years on Tezos. It's an environment that's familiar to them, so every application on Tezos can upgrade to Tezlink. And the idea is that Tezlink will run aside from Etherlink, so you'll have instant transfers between the two. So it's two environments, but one rollup, and more. And so later, all of that migrates into a canonical rollup. So if I had to have an advice for the Ethereum ecosystem, it was just my 2 cents. I would say align on a canonical Ethereum rollup. Just build one, and I think this is something where the Serum Foundation could probably send a strong signal. Even though it's not, it doesn't have any special right, it can be used as a sharing point. So just basically designate one and say this is a network extension of Ethereum. It's not, some rollup that someone built. That's the one. And then draw from the best of optimistic design. Don't wait for ZK. I am so excited for relativity rollups. I think my idea on scaling in 2017, I wrote a blog post about how sharding was not the right way to scale, that you could scale with zero knowledge proofs. That has become one of the dominant paradigm out there since then. And nevertheless, despite this being my opinion at one point, I say today, if you really want to be able to run anything you want on a rollup, don't wait for validity, run with optimistic rollups. Especially if they're enshrined, you have very, very good guarantees with them, because in practice, you're not going to be running those refutation games. And so, and now, I promise this was my bait, AI agents and Memecoins, so I'll give my few cents on this. Let's see. Well, first of all, modern AI models kind of suck at being agentic. They're really, they're very smart. They know a lot of things. They're now very, very good with reasoning. Agentic behavior is kind of the weakest point at the moment. And so, yeah, people are making a big deal out of using AI agents in crypto. I think it's mostly hype. At the minimum, if you're going to do it, at least run it on some kind of on some kind of trusted environment, so that at least it has it's meaningfully independent. I think it's fun, but to see it as a new paradigm, it's just basically essentially it's trying to create hype around well, everyone can see this technology is important. It's not really related to what we're doing, because fundamentally these things are accounting systems, but people are trying to make it so that say, oh, buy a token and you get exposure to this new technology that's emerging. But it's not really that. So I'm not saying they're never useful, but they're definitely way overhyped compared to their actual connection to what it is that we're building. And meme coins, yeah, again, I think that a lot of coins are meme coins by definition. Fundamentally, if you're a store of value, you're a meme coin. But by that, what I would say is it comes from, it's also sharing points. People just agree to ascribe value to a thing. Sometimes it's sticky, sometimes it's not. Obviously, a lot of the meme coins which are launching today, they don't intend to be sticky. They intend to be mostly a roller coaster. There's not much to it, right? It's a gambling application, and gambling has always been one of the most popular use cases in crypto, and so I think it'll continue to be a popular use case. But if you are thinking that they're about building communities or anything like that, you are really fooling yourself. So, sure, make them, they're fun, and people like to gamble, but don't pretend that they're more than that. All right, that concludes my presentation. Thank you so much for coming, and check out Tezos X, and also check out Etherlink. Bye-bye.